everyone, welcome back. In this part of the tutorial, we will go over how to upload a Unreal Engine server build to Amazon GameLift, as well as how to create a fleet with your game server build. We will be using the AWS CLI, short for Command Line Interface, to upload our server build, and we'll use the GameLift console to create our fleet. This fleet can contain many EC2 instances, which again represents that virtual server rack from the graphic that we saw in part 1. Each of these instances will run a variable amount of server processes, which you can configure in the GameLift console and in the command line, but for this tutorial we'll keep it simple and stick to the console, mainly for configuring fleet settings. A server process is just a fancy way of saying your game's server executable. And once these server processes are running, throughout their lifespans on the instance they are running on, they will communicate back and forth with the GameLift service through the GameLift Server SDK that we talked about in the last part of the tutorial. But we are still missing something very important, an AWS account, and the only way we can use the GameLift console and the AWS Command Line Interface is through an Amazon Web Services account. So if you don't have one, go to the AWS homepage, the link will be in the description below, and create an account through here. And once you are finished, or if you already have an account, then just proceed to sign into your account. After you have signed into your AWS account, you should see the AWS Management Console. The first thing we are going to do is create a IAM user and attach a policy to that user that will allow it to call GameLift functions so that we can configure our AWS command line to use this user's credentials. Therefore, we will be able to call GameLift functions in the command prompt while representing this user. So from here, look up IAM, click on IAM, and then on the left under Access Management, click on Policies, and then click on Create Policy, and then click on the JSON tab. Expand these square brackets, then write out some squiggly brackets, and then write out effect in quotes, and then colon, allow, in quotes, and then comma, action, colon, GameLift, colon, star, and then comma again, and then resource, colon, star, in quotes. And then click on review policy, name this policy Amazon GameLift Full Access, and click create policy. Remember, the name says it. Whichever user you attach this policy to will have full access to GameLift. So be careful and only attach this policy to users you trust. With that said, let's go ahead and actually create the user. So back on the left under where it says Access Management, click on Users, then click on Add User. And for the username, feel free to call this user whatever you want. I will name it after myself since I will be the one using this user's credentials. So I'm going to type out Chris. And for the access type, only select the checkbox by where it says Programmatic Access. Then click on Next Permissions, and then click on Attach Existing Policies directly. And below that, search in the search bar the name of the policy we just made. So type out Amazon GameLift Full Access, and select the checkbox by that policy. Then click on Next Tags, Next Review, and Create User. Now, the credentials we were just talking about will be in the form of a access key and a secret access key like the ones you see here in the middle of the screen. Feel free to click the show button underneath where it says secret access key so that you can see the value. These keys will be directly used to configure your AWS CLI, so copy and paste these values to a safe place and do not share them with anyone. They should only be known to you. Once these values are stored in a secret place, go ahead and click the close button. To actually use the keys we just made, we need to install the AWS Command Line Interface. So go to the AWS CLI webpage, link will be in the description below, and click on the 64-bit button under where it says Windows in order to download the installer. Once the installer is finished downloading, let's start it up, and click on Next. Click on I accept the terms in the license agreement, and click on Next again. Click on Next, and click on Install. If you want to allow this app to make changes to your device, just select yes and let the installation proceed. Once the installation has finished, click the Finish button, and let's go ahead and configure our AWS CLI. So open up Command Prompt and type out AWS configure and press Enter. Now for the AWS access key ID value, just get that access key you stored before and paste it here, press enter. And then for the secret access key, just get the secret access key that you stored before and paste it here, press enter. And the default region name here is US East 1, and for this tutorial we will be operating in the region defined by that region code US East 1. We'll have in the description below a link to all the AWS regions. So once you're here, just type out the region code. So in my case it'll be US East 1. I know that by default it is US East 1, but I'm just typing it out here to show you guys that if you want to change it to a different region, you would have to type out the code. Press enter, and the default output format is JSON, which is fine, so press enter. We have all we need now to upload the server build to GameLift, but before we upload the server build to GameLift, what I personally like to do is make sure that the server build is working with GameLift locally. Uploading the build and creating a fleet generally takes a very long time, so I highly recommend trying to run locally first. So close out of this, and let's go back to File Explorer, specifically where we put that server SDK folder from the last part of the tutorial. Open it up, then go to the GameLift folder, and then I'm just going to drag this GameLift Local folder to my Downloads folder. Let's start GameLift Local now by opening up Command Prompt and cding into that GameLift Local directory, and type out java-jar GameLiftLocal.jar-p9080 and press enter. And this will start GameLift Local, and by default the program will listen for client requests on port 8080, but since we specified an optional -p parameter in the command, this specific running GameLift Local program will listen on port 9080 instead. And of course we have to run our server build as well, so let's open up another instance of Command Prompt. And before we do anything, let's go to File Explorer, specifically in the project folder, and remember from the last part of the tutorial that our package server build is in this Windows Server folder, so double click that, then open GameLift Tutorial, then binaries, then Win64. And when we actually start a fleet on GameLift, all the server processes in the instances in that fleet will actually be running this executable in this binaries folder. So let's cd into this folder and run our server by typing out GameLiftTutorialServer.exe -log to enable logs and -port equal 7779 to pass a port value to the process, and press enter. This command will open up a new command prompt for the server so we can close the one behind this and maximize the new one. First thing that you'll notice in this log window is that the IPNet driver is listing on port 7779. That means the process is actually using our port parameter. If you go back to the command prompt running GameLift Local, you will notice a few things. 1. GameLift is acknowledging that our server called process ready. 2. GameLift is using the log file path that we specified, which in this case is a log file.txt. And 3, the on health check function is being invoked by GameLift every 60 seconds, and our server is responding back saying that it is indeed healthy. Let's now open up command prompt once again so that we can start making client requests for the AWS CLI. So let's type out AWS GameLift create -game -session. Create game session is the command that we will be using to create a game session, and it takes in a few parameters. The first one is --endpoint-url. And we're going to set that equal to http://localhost:9080. The port in this endpoint URL has to correspond with what we specified when running GameLift Local. And the next parameter will be --maximum-player-session-count, and we're going to set that to 2. This number is arbitrary, it can be anything, it's just that it is a required field for this command. And then the last parameter will be --fleet-id, and we're going to set that equal to fleet-123. This command will take in any valid string for this parameter as long as it starts with fleet-. Press enter to run, and this command, as you can see, just returned a game session object of status active. But let's go back to the command prompt for GameLift Local, and you'll see a couple things here. So if I highlight this message here, finish sending event to game server to start a game session. So that basically means that the onStartGameSession function was invoked by GameLift because it wants to start a game session on our server process. And if you see here, on game session activate, our server process clearly responded back saying we've received the request and we are going to start a game session. And if we go back to the command prompt where we ran create game session, this command returned a game session object with status active, confirming that we have successfully created a game session on the server process running on port 7779. Just a warning, sometimes the create game session command will look like it's stuck. If that is the case, then go back to the command prompt where you ran GameLift Local and just press enter. And if create game session returned a game session object of status activating, that's okay because sometimes the server process didn't call activate game session by the time create game session was finished. So to make sure that there's an active game session, let's go back to our other command prompt here and let's type out AWS GameLift describe -game -sessions. This describe game sessions command gets us all the game sessions on a fleet, and it takes in a couple of parameters. The first one will be --endpoint -URL. We're going to pass in http://localhost-:9080. And this is the same parameter we just used for create game session, and the next parameter will be --fleet-id fleet123. Again, same parameter here as well that we used for create game session. And then just press enter. And you'll notice that once again, it just returns the same game session from before, but maybe for you this time, instead of being in activating status, it's in active status. And if everything kind of went the way it went for me in this video as we ran GameLift Local, our server process, and these couple of GameLift commands in the command prompt, then let's just go ahead and finally upload our server build to GameLift. But before we do that, we actually still need 2 more files for our server build to run successfully on an EC2 instance. One of them is the Visual C++ redistributable file. This file is basically a dynamic link library file that is required by programs that were built in Visual Studio. Without this file, these programs can't run, including our Unreal Engine project, which was built in Visual Studio. The link to the download for this file will be in the description below. To download this file, just click on down here where it says vcredist.x64.exe. Now open your redistributable file in File Explorer and go to your project server build directory and open that in File Explorer as well. And copy the redistributable file and paste that into that directory. The other file we need for our packaged server build is the install.bat file, which will get run when the fleet initializes so that each instance on that fleet has the necessary programs installed in order to run our game server. So let's open up Notepad and let's start typing out vc_redist.x64.exe/q, and then on the next line let's type out engine /extras /n-us /UE for prereq setup _x64.exe/q. And these lines will run the redistributable file as well as the UE4 prereq setup file, and the UE4 prereq setup executable just installs programs needed to run games built in Unreal Engine. So let's go ahead and save this by going to File, Save As, and once again save this in your project's server build folder. So let's call this install.bat. So we need the .bat extension to make this a batch file, and just click on save. With those 2 files now added, we can finally upload our build to GameLift, and to do that, let's go back to command prompt and start typing out AWS GameLift upload-build, and then this is going to take in a lot of parameters here. The first one is going to be --name, which is going to be the name of our server build, which I'm going to just call GameLiftTutorial, and then --build-version, and I'm going to make the version 1.0.0, and then --build-root. This will be the path of the directory containing your server build. So in my case, it's going to be c:/users/chris/documents/unreal projects/GameLiftTutorial/Windows server. Since my path includes spaces because my Unreal Projects folder has a space in its name, I have to put this parameter in double quotes. Otherwise, I'm going to get an error. And then after that, the next parameter is --operating-system. And this is basically for you to specify whether or not this is a Windows server build or a Linux server build. For us, it's going to be a Windows server build, so type out Windows_2012, and then --region is the last parameter. And in this tutorial, again, we're going to be using the region code US-East-1, and then press enter. Just want to say really quickly, the name and build version parameters for the upload build command can be absolutely anything. There is no significance behind GameLift Tutorial and 1.0.0. I could have made the name anything, as well as the build version. But if the upload has finished and was successful, let's go back to the AWS Management Console, type out GameLift here in the search bar, and click on Amazon GameLift so that we can go to the Amazon GameLift dashboard. Here we are going to create a fleet by clicking on the name of our build, clicking on the Actions drop-down menu, and selecting Create Fleet from Build. Before we start filling in the fields on this page, I just want to point out that if there's a circle with the letter I inside it by a field, I highly encourage that you hover your mouse over that circle and read the information that it gives you about the field. Moving on, we can name this fleet pretty much whatever we want, so I'm just going to name it GameLiftTutorial Fleet. The description is optional, so I'm going to leave that blank. For the fleet type, you can decide for this fleet whether the instances that your server processes will be running on are going to be on-demand instances or spot instances. Let's just quickly go over the difference. On-demand instances are created for you whenever you want them. If you need an instance right now, you can always acquire an on-demand instance, and you can keep it for however long you need it because you pay a more expensive fixed cost for the amount of time you do use them. And you can always get rid of them whenever you want to. There's no long-term commitments. Spot instances, on the other hand, are essentially unused, leftover AWS computing resources, which makes them less expensive, but also less available. And they're prone to fluctuation in many ways. For example, the price is not fixed like it is for an on-demand instance. The price of a spot instance will fluctuate based on the supply and demand of the instance type in the region you're in. We'll get into instance types soon because instance type in this case does not refer to spot and demand. It refers to the type of hardware used by the instance. Another example is what we mentioned in the last part of the tutorial, in that spot instances can be interrupted and your server processes on those instances will have to shut down so that AWS can use those instances for something else. However, GameLift has a service called Fleet IQ running in the background that drastically reduces the chances of these quote-unquote spot interruptions from happening, which will allow us to use spot fleets, take advantage of the cheaper pricing, and maintain high game server availability. So let's go ahead and click on this fleet type field and select spot, because we want spot instances in our fleet. Just a note though, with spot fleets, game session creation has to be done through a queue because Fleet IQ uses that queue to calculate what instance type to use, what fleet type to use, and even what region to use when placing a game session. All of these factors help Fleet IQ select the best available fleet based on cost, interruption rate, and player latency. And creating game session won't be done through the create game session method that we used earlier in the command line. It will be through other functions that utilize a queue, such as start game session placement and start matchmaking. For this tutorial, since we're going to be focusing on matchmaking, we're probably going to be doing it through start matchmaking. Next up is metric group. This is used for aggregating metrics for multiple fleets by assigning this field in those fleets to the same metric group so that you can view all the logs for these various fleets in CloudWatch in one location. This field is optional and I won't go in depth into this, so just leave it blank. The instance role ARN field is also optional and I won't be covering it that much, but for those who are interested, remember when we made that IAM policy and attached it to a IAM user to give that user specific permissions, which in that case was full access to GameLift? Well, this field is pretty much the same thing, except you're attaching what is called a role to this fleet, giving this fleet specific access to specific AWS services, thereby giving all the server processes running on all the instances in this fleet these same access and privileges. For example, if you want your game server to directly write to and read from a table in DynamoDB, you could attach a role to the fleet through this field that would give the server build permission to write to and read from that table. The only reason they call it a role instead of a policy is that policies are for users and groups while roles are for actors. So another example of an actor that we will look into later is a AWS Lambda function. But yeah, we won't be using it here since it would make the game server a little more complicated to write if we did use the access permitted by the IAM role, but I would highly encourage you to read more about it on your own. Link will be in the description below. So let's just leave it at that and leave this field blank. Next up is certificate type. Now let me just click on this to show you the two options which are disabled and generated. This field is for whether or not you want GameLift to generate a TLS certificate for the fleet so that when your client establishes a connection with your game server, your client can authenticate the server by using the TLS certificate sent back by the server to the client. And the certificate contains many things including a public key for encryption. To authenticate the server, the client will check if the certificate is valid and verify the identity of the server with the certificate authority that issued the certificate, essentially confirming that the server is who it says it is. If the client successfully authenticated the server and deems it as trustworthy, then the client can use the public key in the certificate to encrypt a randomly generated secret value and send that to the server. And the server can use its private key to decrypt that secret value. Both the client and server will then use that same secret value to generate one session key used for both encryption and decryption, going from asymmetric encryption/decryption to symmetric encryption/decryption. Now, data sent and received from the client and server from this point on can be encrypted and decrypted with the same session key. If any of this was confusing, this is known as the TLS handshake, and we will have a link in the description below for more information about this. TLS certificates are definitely very powerful and useful for securing your applications. We won't go over how to use them in this tutorial, so just keep this field as disabled, but if you have time, then I highly encourage that you look into TLS certificates and TLS handshake. For the binary type field, there are two options, build and script. The build option is for custom game server builds like our Unreal Engine server build. The script option is for real-time servers, which are in the form of a script written in JavaScript. The main benefit of real-time servers is that they are more lightweight and that you can literally update them at any time almost instantly. So if I had to make a quick change to my server code and run it on GameLift, it would be very, very fast to do that. We wouldn't have to upload a new build nor create a new fleet. But Unreal Engine server builds are very powerful and have a lot of functionality that you don't have to write out. So just leave this selected as build. That deselected our build field, so let's click on this field and reselect our game server build that we just uploaded, which in my case was called GameLiftTutorial. And again, this build will be the server process running on all the Windows EC2 instances on this fleet. Alright, scrolling down to where it says instance type, this is where you select a instance type which defines the computing hardware and resources used to run your server processes. Each option gives you information about the family, which is what the instance type is meant for. So for example, we have instances meant for being optimized for computing. If we scroll down here, we also have instances that are meant for being optimized for memory, as well as for general purpose. And then we have the instance type here, which is just a name. And then we have the vCPU tab, which is how many virtual cores are allocated to these instance types. We also have the memory allocated for these instance types. We have the network performance of each instance type, as well as the pricing history on the far right for each instance type. For this tutorial, we are just going to select the C5.large instance type because that is the cheapest one and is eligible for the free tier. Rule of thumb is the more resources you want, the more you have to pay for them. Alright, scroll down to where it says server process allocation, and this is where we specify how many instances of our game server we want to run on each instance. For the launch path, let's go back to File Explorer, specifically in the binaries folder in our server build directory, and copy the path up to but not including Windows Server. And then paste that into this launch path field here. And let's finish this field by typing in / the name of our server executable, which is GameLiftTutorialServer.exe. And then for the launch parameters, let's specify our port by typing -port equals 7777 this time. And the concurrent processes field defines how many server processes of the specific configuration can run on each instance simultaneously. So how many times can we run GameLiftTutorialServer.exe with the -port equals 7777 parameter passed to it on each instance? I could make this number 2, and each instance would be able to now run 2 instances of our server build with this exact configuration. Now, for this tutorial, I probably wouldn't recommend that just because having 2 processes listening on the same port may not be the best for the free tier C5.large instance. Since there aren't that many resources on the free tier instance, we should probably try to avoid increasing network traffic on a single port because I'm not sure how much traffic the instance can handle on one port. So let's set that back to 1. Don't quote me on this though, I could actually be pretty wrong about this, but even with the free tier we can avoid this and still run multiple server processes by clicking this add configuration button. And just use the same launch path field we used up here as well as these same launch parameters. But this time maybe change the port parameter to be 7778 instead. And these settings will make it so that there are now 2 game servers running on each instance. One on port 7777 and the other on port 7778. To confirm these settings, just click on the green checkmark button on the far right side for each configuration. Underneath that, we have the game session activation section, where you can configure how many game sessions can activate at once on a single instance. This is more useful when you have a lot more server processes running on each instance because, like the description says here, invoking the onStart game session callback function and calling activate game session on too many server processes in an instance simultaneously can put a lot of strain on the instance and even throttle it a bit. To better control the number of game session activations happening at once, you can play with the max concurrent game session activation as well as the new activation timeout fields. But for this basic tutorial, we are going to leave these settings alone using their default values. Next up are the EC2 port settings. So let's go down here and click add port settings so that we can configure a range of ports for the server to use for allowing inbound connection. So for the port range, let's do 7777-7778 since we use those 2 ports for listening in the 2 server processes we allocated above. For protocols, select TCP, but then click on UDP. So unlike TCP, we don't have to establish a connection between the sender and receiver before data can be exchanged when using the UDP protocol. And for IP address, type in 0.0.0.0/0 to allow anyone access to connect, and click on the green check mark to save those changes. Last but not least, the protection policy allows you to apply game session protection to instances in this fleet. Instances with protection on are not terminated during a scale down event if they are hosting an active game session. Note that this does not protect your server processes from spot interruptions. This setting applies to cases where instances are scaled down because of many reasons. For example, you have a scaling policy that automatically scales the number of instances in a fleet up and down, or you manually lowered the fleet instance capacity when you were using max capacity. For most of this tutorial, I'm going to leave this field to be no protection because I'm not sure how much in depth this tutorial will go into scaling. The other option is full protection, which will apply the instance protection we just talked about. But again, just stick with no protection for this tutorial. Finally, let's create our build by clicking on Initialize Fleet. The fleet initialization process will take a very long time, so feel free to take a break. To check on the progress of your fleet, you can go to the Events tab here and refresh it to get the latest status of your fleet. Once your fleet is in the active state and you see events in the Events tab saying Fleet State Active and Fleet Scaling Event, then congratulations, you have successfully created a fleet for your server build on GameLift. And one thing you'll notice here is that under where it says active instances, the number of instances currently running on this fleet is 1. That is because by default, the number of desired instances, quote unquote, is 1. So if we go to the scaling tab, you can actually change that number under where it says auto scaling policies, specifically where it says manually adjust the desired instance count. And again, by default, it's 1. And in this tab, under where it says instance limits, you can also set the minimum instance count as well as the maximum instance count. And down here, there's some stuff related to scaling that we won't go in depth into this part of the tutorial. If we go back up, you'll also notice that under where it says active servers that there are 2 active servers. That's because we allocated 2 server processes to run on each instance. One on port 7777 and another on port 7778. One more thing we're going to do is create a queue because like we mentioned earlier, since we are using spot fleets, game session creation has to be through a queue so that we can take advantage of matchmaking features in GameLift, as well as the Fleet IQ service that helps improve player latency, reduce the rate at which spot interruptions happen, and reduce cost. So let's go up here where it says fleets, click on that and select queues, and then click on the create queue button. For the name, we can call this anything, so I'm just going to call this GameLiftTutorial queue. For the queue timeout field, we are going to just use the default value of 600 seconds. Essentially, requests made to create a new game session on one of the server processes on one of the instances in one of the fleets in this queue will time out after 600 seconds if the request was not fulfilled. Moving on, player latency policies are basically policies that you can add to enforce a maximum player latency limit for all the potential players in a new game session. Let's click on add player latency policy here, and using this default policy, spend the remaining queue timeout searching for a destination where all player latencies are less than 150 milliseconds. When the queue gets a new game session placement request, the queue spends up to 600 seconds, usually less than that, to find the fleet in a region where all the player latencies are less than 150 milliseconds. So I'll give a dummy example. Let's say we had 2 fleets in this queue. First one is in region US East 1, and the second one is in region US West 1. If there's a new game session request involving 3 players, in region US East 1, 2 of those players have a latency of 20 milliseconds, but the third player has a latency of 200 milliseconds. While in region US West 1, all 3 players have a latency of 100 milliseconds. Because of the policy we have here, the queue would place a new game session in the fleet in region US West 1. Now we can add more player latency policies by clicking the button again. And notice how the policy that was originally there was bumped down. That is because the policies are applied and listed in ascending latency maximum order. So the second policy is a relaxed expansion on the first policy. So we can make this first policy spend 100 seconds searching for a destination where all player latencies are less than 100 milliseconds. Now, if we have an incoming game session placement request, the queue will spend 100 seconds at first to find the fleet in a region where all the player latencies will be less than 100 milliseconds. And if it can't do so by the time 100 seconds passes by, then it will use the remaining 500 seconds of the queue timeout to find a fleet in a region where all the latencies are less than 150 milliseconds. And you can keep adding policies so long as you're operating within the queue timeout and the policies are ordered in ascending latency maximum order. For most of this tutorial though, we can get rid of the player latency policies, so just click on this X button here. Because we'll be primarily using one fleet in this queue, therefore one region, so player latency policies won't help us that much. Towards the end of the tutorial, I'll explain more in depth the multi-regional advantages of queues. Lastly, under where it says destinations, this is where we add our fleet to the queue so that the queue can use our fleet as a destination for creating new game sessions. So click on add destination, and for the region, just select the region you're using. We are using US East 1, and for the type, select fleet, and for the fleet or alias name, just select the fleet that you just made. And then click on the green check mark to save your changes. Although we are not using multiple fleets right now, just know that if you had multiple fleets in this queue, you could order them by priority, so the queue would try its best to place game sessions on higher priority fleets first, before placing sessions on lower priority fleets. And you can adjust the priority of a fleet by clicking these arrow buttons here on the left side. Once that's all done, click on the Create Queue button to create your queue. And that will do it for this part of the tutorial. We were able to upload our server build to GameLift, create a fleet for that build, and add that fleet to a queue. So thank you guys for watching. Be sure to like, comment, and subscribe. Special thanks to our patrons and donors. Join our Discord, follow us on our other social medias, and see you guys in part 4.